Alright, this is the second half of your review. First problem asks us to graph the system of linear inequality. So y is less than 3, y is greater than or equal to negative 3x, and y is greater than x minus 3. So y is less than 3. So that's going to be a horizontal line at 3. It's going to be dashed because it's just a less than, and it would be shaded below. Our next one, y is greater than or equal to negative 3x. So this has a y-intercept of 0 and a slope of negative 3. So I know it goes over 1 and down 3. If I went back 1, it'd go up over 1 and up 3. This is going to be a solid line, and it's also going to be shaded below. And then my last one is x minus 3. So this is going to have an intercept of 3, and it's going to go has a slope of 1, so it's going to go up 1 and over 1. It's going to be dashed or dotted because it's a greater than, and it's going to be shaded above. Okay, so below, below, and above. So that's going to be this region right in here. Number 27. So I want to get these into slope-intercept form. So I'm going to subtract x from both sides. So that gives me y is greater than or equal to negative x plus 5. Subtract x. Negative y is less than or equal to negative x plus 2. Divide by negative 1, and I get y is greater than or equal to x minus 2. And then y is less than negative 1. My first line has a y-intercept of 5, and then it goes over 1 and down 1 because it has a slope of negative 1. This is going to be a solid line, and I'm going to shade it above. My next line, y is greater than or equal to x minus 2. So this has a y-intercept of negative 2, and it goes up 1 and over 1 because it has a slope of 1. And it's going to be shaded, it's a solid line, and it's going to be above. My last line, y is less than negative 1. So that's going to be a dotted line and below negative 1. So because this is above and then below, there's nowhere that's going to match all those criteria because this is the only place that's above the first two, and then the only place below here is down here. So this one's going to be no solution. Number 28. Describe the transformations and then graph each function. So I've got a minus 6 on the inside, so that means it went right 6. To graph them, I just go to my calculator and type them in. And then number 3, it has a vertical stretch of 3. And it went down 1. Number 30 says write a rule for the G described by the transformation and then identify the vertex. Alright, so it's a quadratic, has a stretch of 3, a reflection across the x-axis, and it's been moved 4 units to the right. Okay, so I've got G of x equals, now this is a negative because of the reflection, vertical stretch of 3, and then to move it 4 units right, I'm going to have x minus 4 squared. My parent function has a vertex at 0, 0. If I moved 4 units right, then the vertex would be at 4, 0. Graph the function, label the vertex and axis of symmetry. I can see my vertex is going to be at the opposite of my inside, negative 2, 3. My axis of symmetry is the vertical line that goes through it, so x equals negative 2. And to graph it, you can graph it on your calculator. And there's your graph. Graph the function, label the x-axis, vertex, and axis of symmetry. So my x-intercepts are going to be 1 and -3. I know that the axis of symmetry is halfway between those. So halfway between those is going to be at -1. My vertex then is going to have a x-coordinate of -1. If I wanted to type those in, x minus 1 and x plus 3. There's my vertex right there. I could also find it using the minimum function on your graph, but -1, it's at -4. Number 33, write an equation for the parabola shown. Alright, so this time it gives me my directrix. So this opens up and down, so it's going to be in the form of y is equal to 1 over 4p x squared. And my p-value, I know my directrix, y is equal to -p. So -p is equal to -1. So positive p is equal to +1. So y is equal to 1 over 4 x squared. Write an equation of the parabola in intercept form. Alright, so it has intercepts of 11 and 4 and passes through the point 3 and -0.16. So I have to find the a value. So I'm going to put this into intercept form, which is y is equal to a times x minus p, x minus q. So my y value is -0.16 is equal to a, which I'm looking for, my x right here, 3 minus 11, and 3 minus 4. So -0.16 is equal to 3 minus 11 is -8. 3 minus 4 is a -1 times a. So -0.16 is equal to 8a. Divide by 8. -0.16 divided by is -0.02. So in intercept form, this would be y is equal to my a value, -0.02, x minus 11, and x minus 4. Solve the equation. So I have p squared is equal to -36. So I take the square root of both sides. P is equal to the square root of -36 is plus or minus 6i. Number 36, subtract 19. So 2x squared is equal to -19. Divide by 2. X squared is equal to -19 divided by 2. Take the square root. X is equal to plus or minus the square root. I'm going to put an I out front because it's that negative of 19 over 2. Now I can't leave a 2 down here, so I'm going to have to multiply top and bottom by 2. So that's going to be plus or minus I root 38 over, and 2 times 2 is 4, and the square root of 4 is 2. So that's my answer for number 36. Number 37, that quadratic will factor. The numbers that multiply to give me 36 and add to give me 12 are 6 and 6. So 0 is equal to x plus 6 squared. So when that factor is equal to 0, that makes the whole quadratic 0. So x is equal to -6 is the only solution for number 37. Number 38, x squared minus 60 is equal to -84. Add 60 to both sides. X squared is equal to -24. Take the square root. X is equal to plus or minus, I've got an I because it's a negative, and the square root of 24. So when I want to reduce that. So 24 can be written as 4 and 6. 4 is 2 and 2, 6 is 2 and 3. So I have a set of 2's. The square root of 4 is 2. So I could write this as 2i root, and then my numbers that are left over, that's 6. That's my answer to 38. 39. Alright, this one's set up for using square roots because the numbers that multiply to give me 25 and add to give me negative 10 are negative 5 and negative 5. So 25 and negative 10 are negative 5 and negative 5. So x minus 5 squared equals negative 81. Then I can take the square root of both sides, so x minus 5 is equal to plus or minus the square root of negative 81. It's a negative, so it's going to be I. The square root of 81 is 9. Then I want to get x by itself by adding 5 to both sides, so x is equal to 5 plus or minus 9i. That is for 39. Number 40. Yeah, these are all divisible by 4. So I could have x squared plus 2x plus 1 is equal to 1/4. Now the numbers that multiply to give me 1 and add to give me 2 are 1 and 1. So this left side could factor to be x plus 1 squared is equal to 1/4. Take the square root of both sides. X plus 1 is equal to, the square root of 1 is 1. Square root of 4 is 2, so I'm going to have plus or minus a half. Subtract 1 from both sides. X is equal to negative 1 plus or minus a half. This can be simplified to be negative 1 plus a half, which is negative 1/2. Or negative 1 minus a half, which is negative 3 over 2, or negative 1.5. That is for 40. 41. There aren't any numbers that multiply to give me 17 and add to give me 4. You can do this either with completing the square or quadratic formula. We haven't done a quadratic formula yet, so I'm going to go ahead and review that. So quadratic formula, remember, is the opposite, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And here my a value is 1, my b value is 4, and my c value is 17. So negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 17 all over 2 times 1. So negative 4 plus or minus the square root of 16 minus 4 times 1 is 4 times 17 is 68 divided by 2. 16 minus 68 is a negative 52. So negative 4 plus or minus negative 52 is 4 times 13 square, and 4 is 2 times 2. So I could write this as 2i, because it's negative, root 13 over 2. Well, negative 4 and 2 are both divisible by 2. Negative 4 divided by 2 is negative 2. Plus or minus 2 divided by 2 cancels out, I root 13. So that is your solutions to number 41. Number 42, square root of negative 45. So 45, 9 and 5. 9 is 3 and 3. You've got a set of 3's. So you have 3. It's negative I root 5. Number 43. Find the value of c that makes this a perfect square trinomial. Alright, and then write it as the square of a binomial. Well, half of 20 is 10. 10 squared is 100. So this would be s squared plus 20s plus 100. And the binomial would be s plus, and half of 20 was 10, quantity squared. Number 44, find the discriminant and describe the number and types of solutions. Remember, your discriminant is that part of this quadratic formula that's underneath this square root. So b squared minus 4ac. If it is greater than 0, you have 2 real solutions. Equal to 0, you have 1 real solution, and less than 0, you have 2 imaginary. So I need to move this 2 over to this side, so I'll have negative 2x squared minus 3x minus 12. So a is negative 2, b is negative 3, and c is negative 12. So b squared, negative 3 squared minus 4 times negative 2 times negative 12. Negative 3 squared is 9. Negative 4 times a negative 2 is a positive 8. 8 times a negative 12 is a negative 96. 9 minus 96 is a negative 85. That is a negative, so that means, that's my discriminant, negative 85, and that means I'm going to have two imaginary solutions. Number 45. A boy throws a ball in the air. The ball models the path, this models the path of the ball. How long is the ball in the air? So you want to round this to your nearest tenth, so you're going to type this in your calculator. Negative 16x squared plus 28x plus 3. You might want to change your window a little bit. Well, actually, all we're really worried about is where it crosses the x-axis. So we're going to find that by going second calc. Number 2, left bound, right bound, and that is at 1.85. It asks for the nearest tenth of a second, so it's in the ball air 1.9 seconds. 46. So y is equal to, I'm going to type in x minus 7 squared and negative x squared plus 14x minus 47. And I'm looking for where these intersect. So second calc, intersect, arrow close to one of the intersection points, hit enter 3 times, it's at 6, 1, close to my other intersection point, and it's at 8, 1. Same thing right here. Oh, this one, I'm going to do substitution because I've got a y squared. So I'm going to have x squared plus, and instead of y, I'm putting in 5 plus x squared equals 25. So x squared plus, this means x plus 5 times x plus 5. X times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. I'm going to go ahead and subtract this 25 from both sides right now. So I get x squared plus x squared is 2x squared. 5x and 5x is 10x. 25 minus 25 cancels, and this is equal to 0 now because I moved that over. So these are both divisible by 2 and an x. So I'm going to factor that out, and then I'll have x plus 5. So this is factored. My two factors are 2x and x plus 5. So if either of those is equal to 0, that makes the whole thing equal to 0. So x equals 0, and x is equal to negative 5, or my x coordinates of my solutions. Remember, this is a system, so I also have to find the y's. I can find the y's by plugging them back in right here. So y is equal to 5 plus 0, so that would be the point 0, 5. And 5 plus a negative 5, which is 0, so negative 5, 0. Those are my two solutions. Solve the inequality, round decimal answers to the nearest hundredth. So I think it's easiest to do this on your calculator. So I'm going to have negative 1/2 x squared plus 6x. And then right here, I'm going to have 16. Actually, I'm going to go ahead and subtract 16. Nah, I'll leave it like this. My window, I'm going to need to go and see down up to 16. So I'm going to change my y max to go up to 20. So I'm looking where this quadratic is less than 16. So that's going to be any place over in this area and any place over in this area. So from negative infinity to, and I need to find that coordinate, so second calc, 5, and that is 4, so from negative infinity to 4, or it could also be from to infinity. 49. Clear this out. I've got x squared plus 3x and then 14 down here. Here I'm wanting to know where this quadratic is above 14. So again, I'm going to have a negative infinity to a point, or from a point to positive infinity, because this is where it is greater than, which is going to be right over here and right over there. So second calc, intersect. That's negative 5.5. They asked me to round, or sorry, hundredth. Negative 5.53. And 2.53. Perform the operation, write it in standard form. So negative 7 times 5 is negative 35. Negative 7 times negative 8i is a positive 56i. Negative 4i times 5 is, negative 4i times 5 is a negative 20i. And negative 4i times negative 8i is a positive 32i squared. Now what's important right here is that I squared equals negative 1. So this is really 32 times negative 1, or negative 32. So instead of having 32i squared, I'm writing negative 32 right over here. So negative 35 minus 32 is negative 67. 56i minus 20i is a positive 36i.